We measure the world with rulers shaped like US feet, inches, meters, minutes. The pace of a walk becomes a yard. The tick of a clock becomes a second, a day, and we start believing that reality was built to fit our hands. But the universe was not designed around our stride or our heartbeat. If a civilization a million light years away discovered science too, what units would they trust? What language could any mind, anywhere, agree on? There is such a language, and it is not the one our bodies taught us. It lives in the constants of nature and the quantum constant that says energy arrives in packets. Put these together, and the cosmos begins to speak in scales that are not human, not local, not negotiable. They are the grammar of reality. Imagine shrinking the world. A meter collapses to a millimeter, the width of a pencil tip. The millimeter falls to a micrometer, the size of a cell. The cell to a virus. The virus to the scale where atoms float like lanterns in a dark cathedral. Keep going. Past the electron's haze. Drift through the emptiness inside an atom until the nucleus looms like a boulder. Slip past protons and neutrons, each a crowded city where quarks and gluons flicker in ceaseless exchange. Still smaller. Numbers tumble by so fast that language tries to keep up and stumbles. And then the constants take over. Combine the speed of light, gravity, and the quantum of action, and you arrive at a length so small that metaphor strains. We call it the Planck length. It is not simply tiny. It is a signpost. At this scale, our best equations quantum rules on one side. Gravity's curvature on the other both insist on being heard. And they talk over each other. If you try to probe below that scale by packing more and more energy into a smaller and smaller place, you do not get a clearer picture. You get a horizon. Concentrate enough energy and space-time itself can collapse into a microscopic black hole. The question you are asking eats the answer. The act of measurement creates a door you cannot see through. This is not a limit of imagination or a failure of instruments. It is a limit written into the rules. The floorboards of reality might be foamy or discreet or woven in a way our words do not yet hold. But whatever they are, they do not allow us to peek underneath by brute force. Nature protects its smallest secrets with gravity's seal. Turn around. From the smallest imaginable step, take the longest walk. Start with the star that warms us. Sunlight that touches your skin left the solar furnace 8 minutes ago. The distance between here and there is not only kilometers. It is time made visible. Out past the planets, a human-made messenger hums in the dark. Decades after launch, that signal takes hours to get home. Beyond the whisper of our probes is a true emptiness that is not emptiness at all. It is a stage on which time stretches between events, where a hello becomes a history. The nearest star beyond the sun is close by in galactic terms. Its light needs years to cross the gulf. If you could ride a photon, it would be a 4-year voyage just to reach our next-door neighbor. Messages crawl. Promises, once sent, arrive long after the senders have changed. Now widen the view to our city of stars. The Milky Way is a rotating disk of hundreds of billions of suns, spanned by lanes of dust, threaded by fields, bound by a dark halo we cannot see directly. A single beam of light would need 100,000 years to cross the disk from rim to rim. Squint, and the whole galaxy seems like a pinwheel you might hold in your palm. Think in light years, and it becomes a slow river of time disguised as a spiral of stars. Tilt the camera again, and another city comes into the frame. It's larger than ours, blue-white with hard young suns. It is falling toward us through the silent pull of gravity. Andromeda and the Milky Way are on a collision course scheduled not for any calendar we keep, but for the deep schedule of the universe. When they merge, the stars will mostly miss each other, because space is wide even where it is crowded. But orbits will twist, gas will compress, new stars will flare into life from shock and pressure. And what emerges will be a different city than either of its parents. Now point the most sensitive telescope we have at a dark patch of sky no larger than a grain of sand held at arm's length. Let it gather light for days and weeks. What comes back is a field crowded with galaxies, each a history of starbirth and death, each a fossil of conditions long gone where they lived. The deeper the field, the younger the light. Astronomers call this look-back time. It is not poetry. It is bookkeeping. To look far is to look into the past, because light takes time to arrive. We do not only map where things are, we map when they were. Keep climbing this ladder. Think back further than any star, to a time when the universe was hot, dense, and glowing everywhere. When the cosmos expanded and cooled enough for the first atoms to form, light that had been trapped began to move freely. Some of that light has been on its way to us for almost the entire age of the universe. We detect it today as a very faint afterglow that fills all of space almost evenly. We call it the cosmic microwave background. Draw it as a sphere around us, and it looks like a shell, but it is not centered on Earth. It is centered on every observer, everywhere. The afterglow is not a wall, but a horizon. The oldest picture any telescope can take because, before that instant, the universe was opaque. Here's the quiet twist that breaks intuition. The place that emitted that ancient light is not where we see it. While the light has been traveling, space itself has been stretching. The source of the glow has ridden the expansion and is now tens of billions of light-years away in present-day distance. Further than the number of years on the light's journey, time and distance once so simple become lines that cross. The stage has grown under the feet of the actors, so the distance between them now is not the distance between them then. This is not a trick of words but the geometry of a changing cosmos. Confronted with scales like these, a familiar thought moves in with the weight of night. We are tiny, we are brief, we do not matter. A planet around a minor star, one spiral among many, a species whose works fit on a film of air above a thin crust. The feeling is honest. But smallness is not the same as insignificance. A violin string is thin, yet it holds a universe of sound. A few lines of code are short, yet they move machines and money and meaning. The constants of nature will not bend for us, but life has a power the stars do not. It learns. From the moment we learned to count shadows and mark seasons, we have been decoding a language we did not invent. We found that a pendulum's swing tells time, that a prism sorts light into a spectrum, that electricity and magnetism are two faces of one field. We named constants that do not care about our names. We built instruments that reach further than eyes and return evidence that corrects our pride. We have made metal fly beyond the warmth of the sun, listened to the trembling of space-time when black holes collide, smelled the chemistry of worlds we will never touch. We are small, but the network of minds can be long-lived. Knowledge can outlast the bones that carry it. It can move from voice to paper, from paper to silicon, from silicon to whatever comes next. Meaning can scale because memory can dot, if knowledge endures. Influence can spread beyond the room, beyond the city, beyond the age that produced it. A map sketched by one generation becomes a highway for the next. A constant measured by one team becomes the premise for instruments the next century will build. No single person changes the speed of light, but together we change what we can do with the light that reaches us. We learn to narrow errors, to test claims, to separate patterns from coincidence. In time, we do more than look. We steer. We send craft to slingshot around planets using gravity as a tool. We set clocks that keep time so precisely that their altitude above sea level changes their tick. We coordinate a planet's communication through relativity and radio. Small, yes. Temporary, yes. But not powerless. So what is this common language we seek with hypothetical minds far away? It is not feet and inches, or hours and days. It is the web of relations between things that any curious species can discover when it measures and compares and persists. It is the constant speed that ties cause to effect and forbids faster messengers. It is the way mass tells space-time how to curve, and curvature tells light how to travel. It is the quantum of action that refuses to be divided further. It is the way these pieces fit together to produce scales, natural units that turn the universe from a blur of sizes into a set of connected stories. A scientist here and a scientist there would disagree about culture and taste and myth. They would not disagree about the spectrum of hydrogen, or the ratio of a circle's rim to its diameter, or the way light shifts red when space stretches. With that language, we translate the incomprehensible into the almost comprehensible. We build metaphors. We compare the Planck length to distances we can picture. We count the time it takes for signals from our machines to return from the edge of our sun's influence, and call the delay what it is. It's a measure of space written in hours. We say that a galaxy is a city of stars, and that looking far is the same as looking back. A plight keeps our appointments for us. These translations are not mere decorations. They are bridges from the familiar to the true. They let us act with wisdom. They help us decide what to build and what to leave alone. Where curiosity serves and where pride pretends. We also learn to ask better questions. At first we ask, how big am I compared to the universe? The answer, always, is very small. Then we ask, how big is the universe compared to what we can become when we join with others? That question has a different flavor. A single mind is short-lived. A network of minds can carry a project across centuries. Cathedrals took lifetimes to raise. So did the constant refinement of a law of motion, the slow march from guess to equation to test. If we treat knowledge as a commons we tend and not a trophy we hoard, the effect of our smallness is reduced. We are brief, but our good ideas can be longer than we are. The constants are fixed. Our speed of understanding is not. We can squander our time or put it to work translating the universe into stories that our species can carry. We can grow intuition where it fails. Children learn that the sun rises and sets. Later, they learn that Earth turns. Later still, they learn that turns is too simple a word for the choreography of a tilted, wobbling, precessing world around a dynamic star in a moving galaxy in an expanding space. Intuition grows by being wrong, then corrected, then wrong in a more subtle way, then corrected again. The more we learn, the more awe replaces arrogance. When we discover that the smallest questions produce horizons, we become humble about certainty. When we discover that distance is our time and time is geometry and geometry can change, we become careful about words. Humility and care are not footnotes to science. They are its engine. They make room for wonder to be more than a mood. Wonder becomes a method. It is tempting when standing under a sky full of ice-cold diamonds. to think that meaning must be given from outside or not at all. But meaning is not a property of space like curvature is. Meaning is a human achievement, fragile, communal, revisable. It lives in the way we treat each other as we learn, in the patience we extend to questions that refuse easy answers, in the tools we build to make the next question sharper. We will never own the universe. We can only belong to it well. Picture again that far-off civilization. They do not look like us. Their myths do not rhyme with ours. But when they point instruments at hydrogen, they see the same lines. When they clock the delay between event and echo, they infer the same speed for light. When they chase the smallest scales, gravity and quanta lock arms in the same paradox. If ever we meet, our greetings will be gestures of shared measurement before they are exchanges of music or art. The constants will be our first common nouns. From there, stories can grow. We started with a ruler and a heartbeat. We end with a language that does not care how tall we are or how fast our pulse runs. The universe is not obliged to fit our intuition. Our intuition can grow. That is our kind of power, the ability to extend understanding beyond the edge of what felt natural yesterday. The speed of light will not change. The meanings we build with it can. We are small, and we matter, precisely because we can learn to speak the language of the world that made us. Meaning is not measured in meters. It is made in the minds that measure.